these are the definitions that you were supposed to have done for homework. A line that passes through a circle touching it exactly 2 times. So I would recommend you either highlight or underline 2 times. It's called a secant line. The distance around a circle is called the circumference. The longest chord, or the distance across a circle, is the diameter. A collection of points equal distance from a center point is the definition of a circle. A line that touches a circle exactly 1 place. So this one was exactly 2 times, this one's exactly 1, so let's underline the 1. It's going to be tangent. A line segment that connects 2 points on a circle is called a chord. An angle inside of a circle whose vertex is on the circle is called an inscribed angle. So we're going to go ahead and underline the vertex is on the circle, which means that it's a part of the circle. The amount of space inside of a shape, and we're going to add 2D because volume would be for 3D what area is for 2D, right? The distance from the center point to any point on the circle is a radius. An angle whose vertex is the center of the circle. So the difference in that is it's on, this is the center. It's called a central angle. A piece of the circumference of the circle is called an arc. Where a tangent line touches the circle is called the points of tangency. Sorry, I didn't make that blank bigger. And then half the circumference of a circle is called a semicircle. Maybe you'll flip it over, and my copy is really bad. Up in the top, the formula for area of a circle is pi r squared. And the formula for circumference is 2 pi r, or you could also write pi d. So 2 times radius is equal to diameter, right? So what we're going to do is we're going to label all these pieces down here. So radii is the plural of radius. And I'm just going to name one of these. Let's say this one right here. A radius goes from the center to the edge. And we're going to name that as CD. Oh, sorry, that one we just did with CE. This is also a radius, right? Right here. But CE. And this is a line segment because it ends here and here. So we put a line segment on top of it. There's a third one, CA. A radius has to have one of its letters be the center of the circle because it goes from the center to a point on the circle. We've also got chord, which was a line segment that connects 2 points on a circle. So that's going to be like AB. Because both of those are on the outside of the circle. So that is AB. That's also a line segment. We could also say that AD, if I make it a line segment, is a chord. Now if I make it a line like it is here, that's actually going to be a secant line. Because it goes through it. So remember, when I make it a line, I put arrows on it. A line segment does not have arrows. This just tells me that it goes on forever. So AD as a line segment would be a chord, but AD as a line is a secant line. We also have the diameter. Diameter should be an easy one. It goes all the way across, and it is still a line segment, so that's going to be AE. And it's a line segment. There it is. And we named it AE. Tangent line touches the circle exactly 1 time. So you look here, we've got a line like that out here. We can name this a lot of things. It can be FE, it can be FG, it can be EG, as long as you tell me that it's a line. So you call it FE, because that keeps going. EG, that keeps going. And the important thing is that this line is really outside the circle. Only place that it touches the circle even is E. This one goes through the circle. That makes it secant. But it still has stuff outside, which makes it secant instead of a chord. Okay? Let's go to these angles. The central angle has an angle at the center. Inscribed has the angle somewhere on the circle, meaning that it touches the circle. So a central angle is going to have the vertex C. So that means of my three letters, the middle one has to be C. I label an angle with an angle in front, because that tells me what it is. So angle ACD would be a central angle, because it has the vertex C and the two endpoints are part of the circle. We could also have the angle ACE, because it's got the same thing going on. And I didn't ask you for a particular one, I just want you to name one. Right. Go on to inscribed angles. So we're going to look for something that has its angle touching the circle, and then it's got two other ones that are part of the vertices. So I can actually see that one right here. A, B, E would be perfect. It matters that, we can't put B in the middle. Why can't I put B in the middle? There's no line over here, right? If there's a line there, that would be an inscribed angle as well. But we want to switch this. B, A, E. Angle B. Because A is the vertex, right? So it has to go in the middle. There's a couple of things that I didn't put on here that you need to add. We're going to have the center, which is just a point. So the center of the circle is C. I can have the point of tangency, which is just where my tangent line touches it, so that's also a point. If I look at my tangent line, it touches at E, so that's going to be a point E. And you're also going to have to name this circle. So this circle is named with a circle, and then the center point. So this is called circle C. You're not going to usually be asked to tell me the name of the circle, you're just going to be given this, and you're supposed to know that this means circle C. So you put a dot here to help you realize that it's not an O or a 0. So these are the ones that we've really talked about before. We've got line segments, lines, angles, and then we've got some points down here. These two are points. This one's new. But we're also going to talk about these new ones over here, major arc, minor arc, and semicircle. So as you notice with these, I just put what they are on top of them, right? We're going to do the same thing for arcs. So they're going to be a curve. And we're going to start with semicircle because I expect that to be the easiest one. Semicircle is half of the circle. And you have already told me half the circle in another way. The diameter is also half the circle. It just cuts across the circle. The semicircle is half the circle, and it goes around the outside. So whatever my letters are for my diameter, they're also going to be for my semicircle, except for now, it's a curve. So I put a curve on top of it. So this is the arc AC, or AE. I can't even remember what letter I wrote. This is the arc AE. It's a semicircle because AE, the line segment, is a diameter. And this is going to be worth 180 degrees, or half a circle, because a whole circle will be 360. Now we're going to have a minor arc and a major arc, which are related to the semicircle. A minor is going to be less than 180, and a major is going to be more than 180. A minor arc is named with 2 points. So we can just pick 2 points. Anything but A and E, because there is going to make a semicircle, right? So let's do AB. Right? AB would be a minor arc because it is less than 180. But if I went the other direction, that would be a major arc. But I have to know how to say that it's a major arc. I have to be able to identify I'm going the other direction. Because if I just give you 2 letters, you're supposed to assume that you're going in the shortest direction. So what we're going to do is we're going to do A, and then I'm going to tell you that we're going through D, or that we're going through E, and we're going to go to B. So let's go from A to D to B. Now it has to be 3 letters. Even though you go through A, through D and E, you're only telling me one of them, okay? So ADB is going to be the same thing as AEB, okay? Because they got the same endpoints, and they have a letter in between them, telling me that I went this direction instead of the other direction. Okay? So you should be able to do.